All right, so we're going to get into something called curve fitting with linear models. And what we're going to do is basically find the equation of our function, but it's going to be giving us a problem that's got real data in it. So it could be talking about, like, over a period of time, we're talking about sales, whether they're increasing or decreasing, or maybe attendance at a sporting event, or it could be the length of something over time. And so what they're going to ask us to do is to use the data to write an equation. And in order for us to do that, we have to find two important things: slope, and then we have to be able to find like our y-intercept so that we can write our equation for it. Then what they might ask you to do is to use your equation to predict something in the future. So if they're talking about sales of camping equipment, let's just say, they're going to give you information about a couple of different years, and so you can see if the sales have been increasing or decreasing. And then what they might do is say, all right, so let's assume that this trend is continuing on for so many years afterwards. What would the sales be in this year in the future? And you should be able to use your equation to plug in the missing information that you have, and then being able to predict like what their sales would be or something like that. Or it could be, like I said, attendance. It could be anything that they're asking you to predict. When you're given 2 points, we did examples back in that first review chapter where we were able to plug it into our equation to find our slope and to find our y-intercept. So you only need 2 points from a line in order to actually graph the equation or to know the equation. So let me show you an example here. In this first one, it says that in 1970, Joe earned $14,000 a year, and in 2010, he earned $54,000 per year. Fit a linear function to the data points, and then use the function to predict what his salary would be in the year 2017. So first of all, when you try to look at the problem, I'm going to break this into kind of two main parts here. The first one is to use the data that they give you to try to write the equation. So you have to be able to look at the data and understand which numbers are representing like my x coordinates and which ones are representing my y coordinates. So a lot of times x is your independent variable, meaning it kind of does its own thing. It's not reliant on anything else in the problem. So a lot of times things that don't change or are consistent no matter where you are in the world would be like time. Okay, everybody has 365 days a year. Everybody has 24 hours in a day. You know, so years, time, minutes, that kind of stuff, that goes on forever and ever. Things that can change would be how much something's worth over time. Some things either like appreciate or depreciate in value. So that would be an example. In this case, the time, the years would be my x coordinates. His salary is what's changing. So if he's going back to school, he's getting more degrees, maybe he's able to get promotions. All of those things could help him earn more money. So those are things that can change depending on what he's doing. So when I write my coordinates, I'm going to put the year 1970 as my x for my first coordinate, and then the amount of money that he made, which would be $14,000. The other coordinate then would be for the year 2010. So 2010 goes in for my x coordinate, and then 54,000 goes in for the y. So to use these two coordinates, we need to first find our slope. Remember, slope is when we do the y minus y over x minus x. So when you guys look at your points, it doesn't matter which one you put in first. You just have to keep it consistent on the top and on the bottom. A lot of times I try to keep my slope positive if I can. So I usually try to take the bigger number minus the smaller number. So I'm going to do 54,000 minus 14,000. And then the year 2010 minus the year 1970. So 54,000 minus 14,000 is going to be a difference of 40,000. And 40 years has passed. So when I divide those, I get 1,000. So that's my slope. So I'm just going to kind of box it up because I'm going to need that in just a minute. Now that I have slope, to write an equation, we can use what's called point slope form, which looks like this. Y minus y1 equals m times x minus x1. So we talked about slope-intercept form in the last chapter. That was y equals mx plus b. That's what we're going to try to get our equation to end up looking like. But we can start by first using this form, and this is just another form of a line, it's called point slope. So you can see in here we still have the m for slope, and then the x1, y1. That's where you're going to grab one of your points from up here, and you're going to plug that data into x1, y1, and then we'll rearrange this equation so that it's in y equals mx plus b form. It doesn't matter which point you pick. So if there's a certain point, especially if you're using just regular coordinates, if there's a certain point that looks easier, then grab that one. But it really doesn't matter which coordinate you pick here. So I'm going to choose the 1970 14,000 point to use, and then I'm also going to grab my slope here. So I'm going to plug those points into my graph, or into my equation. So I'm going to do y minus the 14,000. And for m, we're going to put 1,000 times x minus 1970. Now what we want to do is simplify this. So I'm going to first distribute 1,000 over here, because I've got that times that portion in the parentheses. So now it says y minus 14,000 equals 1,000 x minus, do your 1970 and add 3 more zeros to it because you took it times 1,000. Then I'm going to add 14,000 over to the other side. This is going to get y by itself. Make sure that you're only adding it to that 197 with the 4 zeros. So you're finally going to have y by itself. So it says y equals 1,000 x, and then it's going to be minus 1,956,000. So 1,956,000 is that number. So this is the equation that we're going to use. This is the equation that they asked for. This is representing, like, over time, what is his salary doing. Okay, so the 1,000, that's representing that, like, every year from 1970 to 2010, he made $1,000 more every year. So every year his salary went up by $1,000. What we can do now is, going back up to that problem, it said, predict his salary in the year 2017. So let's try to find out how much he would have been paid in that year. So 2017, remember, I said that those are like your x values because that's time. And that's your dependent or your independent variable. That's the one that can kind of do whatever it wants. It doesn't matter what else is happening in the problem. So I'm going to take 2017 now and plug it in for my x. And then I'm going to evaluate. And this should tell me how much he's going to make. Now, if we follow the trend, he made 14,000 in 1970. He made 54,000 in 2010. The number should be greater than 54,000 when we do this. Because he should be getting more money over time. So this is going to be step 2. I'm going to use that equation, y equals 1,000, take it times the new year, 2017, and then we're going to subtract that 1,956,000. So you're going to want a calculator to help you do this. So you're going to take 1,000 times 2017 and then subtract. So if you have a calculator, I would encourage you to try to do this real quick. So the number you should get is $61,000. That's how much, if this, trend continues, if he continues to make $1,000 more every year, by the time he gets to 2017, that should be his salary. Now these problems assume that everything stays consistent for the rest of that person's life or whatever they're talking about. We're not looking at situations like if we're talking about sales of something, we're not looking at how one year maybe the sales shot through the roof because it became super popular and then the next year it dropped a whole bunch. We're not paying attention to that. We're just using the information that they gave us. We're assuming that that trend stays the same. That slope is consistent for all these points. Okay, let's look at another one. Okay, this one says that there's a relationship between the height and the length of a woman's humerus bone. If the humerus is 30 centimeters and the woman's height is 154 centimeters, and then if the humerus is 25 centimeters, the height is 140 centimeters. Find or fit a linear function to find this or to use for this data. Use it then to predict the height of someone that has a humerus bone of 27 centimeters. So first thing we want to do is figure out our points. Like what are the coordinates that we're going to use here? So the first one, I would say if the humerus is 30 centimeters, that would be my x. Then the height would be 154. So then the second point we would do is 25 and 140. So we're going to write our equation based off of this data to get started. So slope, we do that first. Take your y's minus your x's. Again, I like to try to keep slope positive. So I'm going to do 154 minus 140. And then 30 minus 25 on the bottom. So I want you guys to do that. You're going to get a decimal for your slope. Get your calculator out. Do that math. It's y's over x's. Yep. So we have 14 over 5. What is 14 divided by 5? Good, 2.8. So there's your slope. Okay, there's m. Now we want to use this, and we want to use one of our points, one of our data points, to write our equation. And we're going to start in that point slope form. Y minus y1 equals m times x minus x1. Again, it doesn't matter what point you pick. So if you just want to go with the first one, 3154, that's fine. And then use your slope 2.8 to kind of plug in the missing information here. So we're going to do y minus the 154, 2.8 times x minus 30. First thing we need to do is distribute. Take 2.8 times x, 2.8 times the negative 30. So I have y minus 154 equals 2.8x. What's 2.8 times negative 30? Good, so we've got minus 84. What's the last thing we should do here to get y all by itself? Good, good. Add 154 to the negative 84. So you're going to have 2.8x plus 70. That's our equation. So part 2 of this problem said to predict the height if the humerus is 27 centimeters. So we were saying that our humerus length, that was our x coordinates. So we're going to plug in 27 now for x, using that equation that we just found. So we're going to take 2.8 times 27 and then add 70. So if you type that in your calculator, tell me what you get for this person's height. Good? And that would be in centimeters, since they're talking about height in centimeters up there in the problem. So these problems are going to look for two main things. They're going to look for your equation, and they're going to look for the answer for your prediction for like what happens next. Now both of those we saw had a positive slope, and so the height was increasing because the length of that bone was getting longer. The last one I have here in your guys' packet is talking about something that's losing value over time. So if things are increasing when the slope is positive, what kind of slope are we going to have then if something's decreasing over time? Negative. Okay, so this example talks about a car's worth. Okay, cars over time, the more you drive them in that, usually they lose value. Okay, there are some exceptions to that rule if we're talking about like a classic type of car. But most of the time, a regular car, if you go and the second you drive it off the lot, it starts to lose value. Okay? Yeah. Yes. So when we're talking about this problem, it says that when it was new, it was $23,000, and after 3 years, it's worth $15,500. So when it was brand new, that would be like year 0. So when we write the coordinate for your first point, it's going to be 0, 23,000. So the second coordinate then would be the 3 years, 15,500. Okay, so why don't you guys try to find your slope here? So no matter how you put these numbers in, one of them is going to be negative because of the way that we set it up. What'd you guys get for your slope? Negative what? Good, 2,500. So that is telling me every year this car is losing $2,500 worth in value. So that's how much it's going down. Now we got to write our equation. So you're going to do your y minus y1 equals m times x minus x1. So take a minute and plug in your point. Pick one of the coordinates. It doesn't matter which one. Plug that in for the x1, y1. Plug in your slope and try to write your equation for this problem. So I'm just showing you using the first coordinate, and it doesn't matter which one you guys use here. Your equation should have said the same thing as me. Negative 2,500 x plus 23,000. Now, to finish this up, let's use this equation to figure out how much this person's car is going to be worth after 8 years. So you're going to take that negative 2,500 times 8 and then add 23,000 to that. So take a minute to do that calculation and then tell me how much is his car going to be worth. How much did we get? 3,000?